Alright, what's going on everyone? I'm Chris and welcome to 0xCB. So here, this is my GitLab security portfolio where I build, attack, and defend applications. Today, I will show you why you need both SAST and DAST in the GitLab CI/CD pipeline. So as a disclaimer, for today's video, we'll be utilizing the target app project. I'll go over here on render. We will go ahead and spin up. Look at that, it's already there. So basically, this website is my Flask app deployed on render itself. So it has a login, register page. These are all active. So these all look normal. However, I did introduce a vulnerability on purpose. So in the code, you can see the safe flag, or filter I should say. So what this does, it tells the app to render whatever the user enters as actual raw HTML, which in theory, it creates a classic stored cross-site scripting vulnerability. Alright, so then next, within the GitLab CI file, for this test, we have the SAST, the SAST. The template is there. And then for the DAST run, we have the scripting here for that as well. Now we'll go back to GitLab itself. For today's video, we'll go ahead and create a new pipeline. And we'll go ahead and just let that run. So for this run, we have container scanning, the secret detection, the SAST, and the DAST. These three will pass. This one will fail. The reason behind that is the configuration of the containers haven't been configured yet. So as this continues to run, we'll go over it a little bit. So my pipeline pulls in GitLab's built-in SAST scanner through that template that was shown earlier. So when I push the vulnerable code, the SAST scanned the source and flagged the misconfiguration within the app.py file, and the debug mode was left on. So that's actually a useful catch. However, once the scan's complete, it'll show that it didn't detect the stored cross-site scripting, because static analysis can't always see the real runtime behaviors. Alright, again, while that continues to run, we'll go over the file itself. So for the DAST job here, this job basically just runs the OWASP zap pipe in the pipeline, and it basically just points it to my deployed render app, and then it will produce a report on what it finds. However, unlike SAST, the DAST scans the live app from the outside, and the results will be flagged runtime. It will flag runtime issues like missing headers, missing CSRF tokens. Things like static analysis actually can't see due to it being static. We'll go ahead and go back, see if the scan is complete, and it's still running. So we'll come back to it once it's done. Alright, so that's complete. Go ahead and open up the SAST. Again, container's not configured, so that's going to fail. And as seen, we have our logs here. In short, it wasn't able to actually find the cross-site scripting vulnerability within the SAST. The DAST was able to find a bunch of vulnerabilities. However, it did not find the cross-site scripting in this case. In future videos, we'll go over these logs more in depth. This is basically just to show these tools in action right now. So go ahead and go back to this. So I have already done this in the past. I actually did it yesterday. So I have my security case studies here. So here we go ahead and have the case study, the breakdown of what had happened, what was done, what tools were used, technologies, etc. Same thing for the SAST, a little bit different formatting. All right, back at the main portfolio. But for today, here's a key takeaway. The SAST and the DAST complement each other. So whereas the SAST catches codes, the issues of those codes early, the DAST actually reveals those runtime misconfigurations. So they complement each other. And in that, together, they give a much better security coverage. However, like I stated before, neither one of them actually flagged the stored XSS. They will need an actual active scan, which again we'll cover in a future video. If you'd like more detail, my full case studies are in the GitLab portfolio. Thanks for watching. I'll see you in the next one.